the last video, we discussed the general launch angle. Now we'll take few examples on the general launch angle. And this is the first example where it says that a golfer hits the ball at an angle 54 degrees above the horizontal, such that the ball crosses over a 3-meter high tree which is 14 meter away from the origin. That is, this distance we have 14 meter. And the ball lands on the ground after traveling a distance of 17.8 meter. So here the distance from the origin is 17.8 meter. So this total distance is 17.8 meter. And the time the ball took to cover this much of distance is 2.24 seconds. So this is the given data, and in the A part we need to find what was the initial speed of the ball. So let us take that the ball is hit with an initial velocity of v0. So let this be v0. Now it will have the x component and the y component. So this will be vx, that should be v0 cosine theta, and this is vy, and this will be v0 sine theta. Now to solve the A part, we're going to study the horizontal and the vertical motion separately. So in the horizontal direction, it travels 17.8 meter in just 2.24 seconds. So we can say that the speed in the x direction, it should be equals to distance over time. Distance is, let it be d. So d over t we can write this way. Distance we have 17.8 meter and time is 2.24 seconds. So from here we'll get the value of vx to be 7.95 meter per second. Now we can easily calculate the value of v0, because v0 we have equals to vx over cosine theta. From this equation we can write this way, and vx we have 7.95 meter per second. Cosine theta we have 54.0 degree, and on further solving we'll get the value of v0 to be 13.5 meter per second. So this will be the initial speed of the ball and the answer for the A part. Now next we have to find how high was the ball when it passed directly over the tree. Basically what we have to find is, when the ball passes over the tree, what was the y value? And x value we already know, this is 14 meter, but we don't know the y value, how high the ball was. So if we are able to find the y value, we can get the answer, right? So for that, what I'm going to do is, I'll first find the time in which the ball covered 14 meter horizontal distance. So for that we can use the horizontal motions equation, which is x is equals to v0 cosine theta times t. And if you are having any issues that how we are able to got this equation, if you just remember this equation, which is x equals to x0 plus v0 x times t plus 1 over 2 axt square. This is the basic fundamental equation, and there is no acceleration in the x direction, so this whole term will be 0. And initially the position of the ball is at origin, which is x0 equals to 0, so this term is also 0. So we obtain that x is equals to, and v0 x we have v0 cosine theta times t. This is how we obtain this equation. That will be equals to v0, we already know it is 7.95. Cosine theta is 54.0 degrees, and the x value we have 14 meter times this t here. Now from here we can easily find the value of t, and the value of t comes out to be as 1.76 seconds. Now I'll use the position as a function of time in the vertical direction. So we have this equation, y is equals to v0 sine theta multiplied with t minus 1 over 2 gt square. And if you have any confusion how we obtain this equation, you can view my previous video. Okay, so v0 we have this is 13.5, so 13.5 meter per second. Sine theta is 54.0 degrees, and time we have 1.76 seconds. Then minus 1 over 2, g is 9.81 meter per second squared, t is 1.76 seconds and its whole square. On further solving, we'll get the value of y to be 4.03 meter. So this y value, or this y coordinate, we have 4.03 meter, or we can say this height is 4.03 meter. So this is the answer for the B part. So here we are given that a trained dolphin jumps directly towards a ball with an initial speed of 12.0 meter per second, and the horizontal and vertical distance between the ball and the dolphin is 5.50 meter and 4.10 meter respectively. Now, in the absence of gravity, the dolphin would have followed this path. It would have gone straight to the ball. But because of the gravity, the dolphin follows this path, the parabolic path. And if the trainer releases the ball at the instant the dolphin leaves the water, then we need to show that when the dolphin travels 5.50 meter in horizontal, its height above the water is same as the height of the ball above water. So what we're going to do is, we'll first calculate the time the dolphin travels 5.50 meter in horizontal, and then we'll calculate the y value at this time. And similarly, we'll calculate the y value of the ball at the same time. And if the y value for both the object comes out to be as equal, then we can say that the dolphin and the falling ball will meet, otherwise not. Now in our sketch, we have the dolphin leaping from the water at origin, so we can write that x naught is equals to y naught, which is equals to 0. This is for the dolphin. And for the this ball, we have x naught to be equals to 5.50 meter and y naught to be equals to 4.10 meter. Now first of all, we'll calculate the theta for the dolphin, this theta. For this we can use this triangle, this one, OAB, and from here we can write that theta will be equals to tangent inverse the vertical distance, which is 4.10, divided by the horizontal distance, which is 5.50. So on solving, we'll get the value of theta to be 36.7 degrees. Now in respect to the dolphin, the horizontal distance traveled is 5.50 meter. So we can do one thing, we can apply the equations of motion in the horizontal direction. So since acceleration is 0 for the dolphin in the horizontal direction, so ax we have 0, so we can directly write that xd, the distance traveled by the dolphin, is equals to v naught cosine theta times t. And what is this v naught here? V naught is the initial speed of the dolphin. This is v naught, which we are given to be 12.0 meter per second. So this will be 12.0 meter per second times cosine theta, and theta we have calculated to be 36.7 degrees. xd, we have this distance, which is 5.50 meter. This is multiplied with t, and on further solving, we'll get the value of time to be equals to 0.572 seconds. So the dolphin takes this much of time to travel a horizontal distance of 5.50 meter. Now we'll calculate the y value for the dolphin at this time. So for that, we can use this equation, which is y is equals to, this is yd, we can write this is for the dolphin. So v naught sine theta times t minus 1 over 2 gt square. We can put the values. V naught we have 12.0 meter per second. Sine theta is 36.7 degrees, multiplied with time is 0.572, minus 1 over 2, the value of g is 9.81 meter per second squared, times t square is 0.572 and its whole square. We can solve it further and we'll get the value of yd to be equals to 2.50 meter. Now what we're going to do is we'll calculate the value of y for the ball at this time. In respect to the ball, we can write that this time we can write yb, b for ball. So this will be equals to h minus 1 over 2 gt square. And what is this h? H is this height. And if you have any confusion that how we are able to write this equation, it's pretty simple. We're just using the basic equations which are like y equals to y naught plus v naught y times t plus 1 over 2 a y t square, right? Y naught is the initial position for the ball, which is h here. V naught y the initial velocity, which is 0, so this whole term goes to 0, and this ay we have minus g in case of football, so this will be minus 1 over 2 gt square. So this is how we are able to obtain this equation. Now simply we have to put the values. H we have 4.10 minus 1 over 2, g is 9.81 times t is 0.572 and it's squared. Since we have put all the values in the SI unit, we'll get the answer in the SI unit, which will be 2.50 meter. And here we see that the y value for both the object at time t equals to 0.572 seconds is 2.50 meter. So the objects will meet. So when this ball falls like this, the dolphin will reach here at this position, and this y value we have obtained to be 2.50 meter for both the object. That is why they will meet. So we have shown that both the objects will meet. Now I'm giving one practice question to you. Everything is same, but there is a little bit change, and the change is that the initial speed for the dolphin is 8.22 meter per second. Then we have to find at what height does the dolphin catch the ball. So this is a question for you that you have to solve. So here we have this low friction cart placed on an inclined track, and the ball is also placed in the cart. When the cart hits the trigger shoots the ball perpendicular to the track. Now the question arises, after the cart hits the trigger, will the ball come back to the cart, or it will fall behind the cart or in front of the cart? Let's see what happens. So we see that the ball comes back to the cart. What is the reason behind it? Try to figure out, and I'll give the reasons in the comment box below after a few days. Okay, so this is all with this video. In the next video, we'll discuss the key characteristics of the projectile motion.